GCP Platform and Cloud Engineering Part 24. This episode has 17 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Design a secure, scalable GCP platform. Here's a strong way to approach it. A secure, scalable GCP platform should start with an enterprise landing zone, shared VPC, private networking, least privilege IAM, logging, SCC, organization policies, and CI or CD with policy checks. Workloads can run on GKE, Cloud Run, or managed services with autoscaling, multi-zone resilience, monitored slows, backup or DR, cost controls, and GitOps or IAC governance. Detailed interview explanation. Secure scalable GCP platform should be explained in terms of what problem it solves on Google Cloud, where it fits in the architecture, and how it affects reliability, security, scalability, and cost. In GCP interviews, do more than name the service. Explain when you would use it, what alternatives exist, and what operational trade-offs matter. Production example. A production GCP platform may use shared VPC, private subnets, Cloud NAT, load balancers, GKE or Cloud Run, artifact registry, secret manager, cloud logging, cloud monitoring, IAM, workload identity, organization policies, and Terraform. Critical systems are usually deployed across zones, monitored with slows, protected with least privilege, and governed with labels, budgets, quotas, and audit logs. Best practices to mention: use least privilege IAM and avoid long-lived service account keys. Prefer private networking and managed services when they fit the requirement. Design for multi-zone availability and define RTO or RPO for critical workloads. Use labels, budgets, quota monitoring, and committed or spot capacity for cost control. Automate provisioning and enforce policy centrally. Common interview follow-ups. Be ready to discuss GKE versus Cloud Run, private versus public networking, IAM troubleshooting, quota exhaustion, load balancer health checks, VPC service controls, cloud armor, cost optimization, and disaster recovery on GCP. Nice. Let's continue. Question 2. How would you explain the role of a senior cloud engineer in improving production reliability? Here's a strong way to approach it. A senior cloud engineer improves production reliability by combining cloud architecture, automation, observability, incident response, and SRE practices. The role is not only to deploy infrastructure but also to reduce incident frequency, improve availability, define slows and sleaze, automate runbooks, and make delivery safer through CI or CD, IAC, and DevSecOps controls. A strong answer should connect engineering decisions to customer impact, service quality, and operational efficiency. Great. Moving on. Question 3. Scenario. Incident volume is increasing across a cloud platform. How would you reduce both volume and severity? Here's a strong way to approach it. Start by classifying incidents by service, severity, root cause, repeat pattern, and customer impact. Then identify top recurring causes such as bad deployments, capacity issues, missing alerts, flaky dependencies, manual changes, or configuration drift. Fixes may include better deployment gates, autoscaling, runbooks, slow-based alerts, Terraform standardization, automated remediation, and post-incident action tracking. Measure progress using incident count, MTTR, change failure rate, and error budget burn. Alright, next question. Question 4. How do you define sleaze and slows for a business-critical application? Here's a strong way to approach it. Start from user-visible journeys such as login, payment, search, API requests, or claims processing. Choose sleaze that reflect customer experience, such as availability, latency, error rate, freshness, or correctness. Define slow targets based on business criticality, historical performance, dependency limits, and cost. Avoid vanity metrics. Slows should drive alerting, error budgets, release decisions, and reliability investment. Let's keep going. Question 5. Scenario. A service has many alerts but users are not affected. What would you do? Here's a strong way to approach it. Review whether alerts are tied to user impacting sleaze or low-level symptoms. Remove noisy alerts. Tune thresholds, add burn rate alerts, and route warnings separately from pages. Keep alerts actionable with clear owners and runbooks. The goal is to reduce alert fatigue while preserving fast detection of real customer impact. On to the next one. Question 6. How do DORA metrics help improve DevOps maturity? Here's a strong way to approach it. DORA metrics measure deployment frequency, lead time for change, change failure rate, and time to restore service. They help teams understand delivery speed and stability together. For a senior role, explain how to use them to find bottlenecks, improve CI/CD, reduce risky changes, and move toward smaller, safer, more frequent releases. Good. Here's another one. Question 7. Scenario. The JD expects weekly deployments or better. How would you improve a team deploying once per month? Here's a strong way to approach it. Break large releases into smaller changes, improve automated tests, standardize branching, adopt trunk-based development where possible, automate build and deployment, add feature flags, and improve rollback, track lead time, deployment frequency, change failure rate, and block PRs. The goal is not speed alone, it is frequent, low-risk delivery. Nice. Let's continue. Question 8. How would you implement trunk-based development in a regulated environment? Here's a strong way to approach it. Use short-lived branches, frequent merges, mandatory pull request checks, automated tests, code owners, static analysis, security scans, and deployment approvals for production. Feature flag separate code integration from feature release. In regulated environments, keep audit trails, change tickets where required, and evidence from CI/CD pipelines. Great. Moving on. Question 9. Scenario. A team has inconsistent branching and release practices. How would you standardize them? Here's a strong way to approach it. Document a simple workflow, align it with CI/CD gates, train teams, and enforce critical controls in repositories. Define branch naming, PR review rules, release tagging, semantic versioning, artifact promotion, rollback, and hotfix process. Standardization should reduce confusion and improve auditability without slowing teams unnecessarily. Alright, next question. Question 10. How do you design a CI/CD pipeline for cloud applications using GitHub, Cloud Build, Artifactory, and Argo CD? Here's a strong way to approach it. Use GitHub for source control and pull request checks, Cloud Build or GitHub Actions for build or test or security stages, Artifactory for immutable artifacts, and Argo CD for GitOps deployment to Kubernetes. The pipeline should include unit tests, integration tests, IAC validation, image scanning, SBOM generation, artifact signing where possible, deployment approvals, progressive rollout, and rollback. Let's keep going. Question 11. Scenario. A deployment through Argo CD is stuck out of sync. How would you troubleshoot it? Here's a strong way to approach it. Check the Argo CD application status, sync errors, target revision, repository access, generated manifests, Helm or customize values, Kubernetes events, RBAC permissions, admission policy failures, and resource health. Compare desired state in Git with live state in the cluster. Avoid manual fixes unless needed for emergency mitigation. Then reconcile the source of truth in Git. On to the next one. Question 12. How do you use infrastructure as code consistently across cloud environments? Here's a strong way to approach it. Use reusable Terraform modules, remote state, version pinning, code review, policy checks, environment separation, naming or tagging standards, and CI validation. Avoid console changes except for emergency break glass scenarios. Consistency comes from modules, golden paths, documentation, and automated enforcement. Good. Here's another one. Question 13. Scenario. Terraform drift is causing production uncertainty. What process would you introduce? Here's a strong way to approach it. Run scheduled drift detection, restrict manual permissions, review audit logs, and classify drift as intentional or accidental. Reconcile by importing approved changes, reverting unauthorized changes, or updating Terraform code. Add governance controls such as IAM restrictions, policy as code, and documented emergency change procedures. Nice. Let's continue. Question 14. How would you structure Terraform modules for a cloud platform team? Here's a strong way to approach it. Create small, composable modules for networking, IAM, Kubernetes clusters, service accounts, storage, databases, monitoring, and application deployment patterns. Version modules, document inputs and outputs, include examples, validate with CI, and avoid overly generic modules that hide risk. Modules should make secure, compliant infrastructure easy to consume. Great. Moving on. Question 15. Scenario. Terraform wants to replace a production resource. How do you handle it? Here's a strong way to approach it. Stop and inspect the plan carefully. Identify whether the change is caused by code, provider version, drift, immutable field change, state issue, or module refactor. Use lifecycle protections for critical resources. Create migration plans. Take backups. Test in lower environments, and get approval before any destructive action. Never blindly apply a risky production plan. Alright, next question. Question 16. How do you secure Terraform state? Here's a strong way to approach it. Store state remotely with restricted IAM, encryption, versioning, and access logging. Separate state by environment and ownership boundary. Avoid storing secrets directly in Terraform state where possible, and never expose sensitive outputs. Use C-controlled applies and review state access periodically. Let's keep going. Question 17. Scenario. A Terraform pipeline passes locally but fails in CI. What would you check? Here's a strong way to approach it. Check Terraform version, provider lock file, backend credentials, workspace selection, environment variables, service account permissions, network access, module source access, and whether CI runs from the expected directory. Make CI the repeatable source of truth by pinning versions and documenting required inputs. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.